No.
Miss Clean thinks I'm smart with Clean, so therefore Clean agrees with smart.
All right. So when we do optimization, we need to follow that VESPA process where we first visualize it, we draw a diagram, so you've got some sort of rectangular area, then we've got a bind on one side, so you just realize that we don't need that there, you can write bind, whatever you want to do. Then, so that's our first V from VESPA. Our next V is to define our variables. Now remember, this is critical, particularly for externals. A lot of you are using variables in your IA2 incorrectly at times. It said displacement was defined as x of t, and you were dealing with the independent variable as x instead of the dependent variable being x. So you've just got to be really careful with those. So we're just going to go let L equal length and W equal width. It does not matter which one you define as length and width. I usually think of length as being longer than width in my head, so I'm going to go that way, but it does not matter. Then, Emily, what's the E? Your favorites, yeah. Equations. All right, so we've got, what do we know about this? We know that the length plus 2 widths is going to equal how much? If I go all the way around, that's the total fence there, equals 40. All right, so that's one equation. And what's the other equation that we know? Area equals length times width. Good. Now, in optimization questions, you are almost always going to form at least 2 equations. And then what do we need to do? You'll need to rearrange, possibly, and then you will need to substitute one equation into the other. So, for example, we are trying to find the maximum area, which means this is the equation in green there that we are trying to optimize, which means we are going to rearrange equation 1, the length plus 2 width equation, and we are going to sub it into equation 2. A equals, now you could have rearranged for width, but I think that would be a bit silly. That's too much like effort. Then you have to divide by 2 and you risk making a silly mistake. So I would have done that one there times W. So area is 40W minus 2W squared. And so that's the S part of VESPA. I'm going to make that part 1 S. That's like substitution. And now we need to actually solve for which value of W gives us the maximum area. Now, 40W minus 2W squared, you should be able to visualize that with confidence as a quadratic. We need to optimize. So this is where we would go a little bit differently to year 11. In year 11, you would have thought, okay, that's a quadratic, and you know that the max happens at where? A turning point. So you might have just gone, okay, turning points happen when x is negative b on 2a. Did anyone use that strategy? No? How did we find our turning point? You found the derivative? You guys are amazing. That's good. That's the year 12 approach. Okay, so turning point or critical points, or we can say max occurs, we'll say critical points, occur when the first derivative equals 0. Now, if you wrote that, f dash of x, I would be looking to take marks away from you. We need to make our function relative to our question. So how would we actually write it down? Derivative of a with respect to w. So we derive a, we get 40 minus 4w equals 0, and we solve that, we get 40 equals 4w, w equals 10. So a critical point is going to happen when w equals 10. How do I now prove that that is a maximum? Second derivative. Okay, so use second derivative. So we're going to sub in W equals 10 into the second derivative. Again, use your notation correctly. So the second derivative is -4. I didn't even have to replace W in there. There was no W to replace. As the second derivative is less than 0, it is a maximum at W equals 10. And so we now are ready to write in our answer. You might have to do some pondering. Oh, sorry. This is what I changed this P in optimization. What do you think the P could be representing in optimization? I sort of hear it. I think. Yeah. Proof. Good. Prove for me that it's a max or a min. You found the critical point. You guys get that. That's fine. Solve for the critical points. But now you have to prove whether or not it's a max or a min. And so therefore the area is maximized when W equals 10. And if W equals 10, we can go back to that original equation up here. That means the length equals 20. Therefore the area equals 200. 20 times 10. Okay, am I getting full marks for that? Units. What are the units? Meters squared. All right. So really, 12D optimization, you have all the tools for 12D. It's just putting a couple of ideas together. I would say you always are pretty much going to, well, most of the time you're going to want to draw a picture, define your variables. Your equations, you ultimately need one equation with one independent variable. So you might need to do some substitution to get there. Solve for your max or your mins. Prove that it's a max or a min. And answer the question that's actually being asked. All right, so you've seen Vespa a few times now. I've just adjusted a couple letters. Thomas. A sign diagram to prove the max or the min. I would say when you don't want to use a sign diagram, overall, my gut to that is no, but Miss Kinnear can jump in if she disagrees. Times that I would be saying you probably don't want to use a sign diagram would be if you got multiple critical points. Let's say you got a critical point at x equals 0 and you got a critical point at x equals a half or something like that. You then need to pick a point in between those. And once you start dealing with that, you're just more likely in a tech-free exam to make a numerical mistake. So I would then be thinking, surely it's going to be way easier to sub x equals 0 into the second derivative than to use a sign diagram. However, is it wrong to use a sign diagram? No. I just think, in my experience, like marking your guys' assessment, that's when I start seeing mistakes. But I think you're fine to use a sign diagram as
Absolutely.
a proof at any stage.
Because obviously when you derive for the second time, it often will simplify down the problem if it's a polynomial, and it might become from a quadratic to a linear, in which case then just subbing into a linear function is so much quicker than subbing into a quadratic, like we were saying, like 3 times. So if your double derivative makes the outcome a lot more complex, then you're going to use a sign diagram in that case, probably to just use the first derivative to test what the different points are, because your double, like to actually derive that second time round is just like, I need to use a quotient rule inside a product rule inside another chain rule. Like if that's what you need to do to find your double derivative, use a sign diagram. If it's just super easy to do that second derivative, then do it.
But neither, like, you're fine either way. Yep. Okay. I think we're good with that. That's fine. All right, guys, so have a crack with that one, please. What dimensions for a 1 liter cylindrical can will use the least amount of material, assuming that there is a lid? Alrighty, so your first step is to draw a picture, probably just to visualize a cylinder. Alright, in another reason that a picture might be useful. Another reason that a picture is useful is you could actually use that as a way to help define your variables to your examiner. So you could draw a picture, and if I say on this picture now, all right, well, here is H and here is R, an examiner can see really clearly, all right, that they're talking about the height and the radius. Particularly when you're using variables that are standard, it just saves you that little bit of time of saying, right, well, H is this and R is that. Okay. So what do we remember about our cylinders? Pi r squared times H, good, is the volume. It is a prism. We remember if I take a slice of this and I do that slice all the way through and I get the same cross section, a uniform cross section, then that shape is a prism. And to find the volume of a prism, you just find the area of the cross section, in this case a circle, pi r squared, and you times it by the perpendicular height. So that's one thing that we know about a cylinder. The other thing is we're talking about the least amount of material. Material, we are thinking surface area. So for the surface area of a prism, sorry, the surface area of a cylinder, you've got the top and bottom. What are the top and bottom? Circles. So 2 pi r squared plus, if we unravel this middle bit here, if you unravel that, it's actually a rectangle. Like if you unwrap it fully, it will become a rectangle. And that rectangle's length is actually the circumference of the circle, 2 pi r, and the rectangle's width is just the height of the cylinder. So it's going to be 2 pi r squared plus 2 pi r h is the surface area of this cylinder. Right, we now have two equations, and our goal is to get to one of the equations, just one equation in terms of one variable, so then we can optimize that equation. So which equation do we want to optimize, the volume or the surface area? The surface area, because it's asking for the least amount of material, so I know I've got to try and optimize that second equation, which means I need to use this left-hand equation some way. I need to do some rearranging there. What else does the question tell us? Excellent. We've got 1 liter of, it's just a 1 liter can. All right, so 1 liter. And this is again where your grade 8 knowledge has got to kick in a bit. What can you tell me about liters? 1,000 cubic centimeters. All right. This content is not explicitly in your Unit 4 syllabus, but it is certainly fair game for your assessment. So we sub in that the volume is 1,000 equals pi r squared h. Which variable should we rearrange for? H. Don't do r. Why would I not do r? Because it's squared and that's just a little bit too much work. So don't make your life harder than it needs to be. All right, so now we are going to sub in this equation here into the surface area, and that gives you 2. Another reason that I think, oh, it's nice if I go for H instead of R, there's only one H in the surface area formula. So less substitution to do. That sounds good to me. Times 1,000 over pi r squared. We simplify if we can. So we've got 2 pi r squared plus 2,000. And I'm just going to write it as r to the -1. So I cancelled out a pi and I cancelled out an r to the power of 1. Now we have one equation, surface area, in terms of one variable, radius. We are now ready to optimize that equation. So to optimize, we find dSA over dr. Find when that equals 0. So dSA over dr is going to be 4 pi r minus 2000 r to the negative 2 equals 0. Is that okay? Yep. Please let me know if I make a mistake. All right, now we need to solve that. What should we do to solve it? Yeah, you could factorize. Any other ideas? Solve. Like if I write this back as a fraction, that might over r squared equals 0. You can factorize if you want. I think that's going to be a little bit harder than just taking the 2000 r squared to the other side and then multiplying both sides by r squared. So we get 4 pi r cubed equals 2000. We get pi r cubed equals 500. Or I'll divide by pi while I'm at it. And I might even take the cube root while I'm at it. Did anyone get that far? Yeah, so we're agreeing with that. Okay, excellent. Back to Thomas's point before, like, can you use a sign diagram or the second derivative test at any time you can? This is probably another one of those examples. Which one would you be leaning towards with this? Would you lean towards a sign diagram or would you lean towards this is a tech-free exam, sign diagram or second derivative test? Hands up for sign diagram. You must pick one. Hands up for second derivative. Okay. My sign diagram crew, do you want to have the floor? Do you want to open the debate? Why? Ash, you got your hand up?
You got some good ideas. I just saw pi.
You saw pi? Why is that leaning towards sign diagram? Oh, you're thinking that sign. I'm talking about this sign diagram. You know, where you've got like your x value and you've got your derivative value and you're trying to prove that it's flat here and there it's positive and there it's negative, therefore it's a maximum.
Why do they call that a sign diagram?
Because it's the sign of the derivative. Is the sign of the derivative positive or negative? S-I-G-N.
That's so stupid.
All right, my second derivative people, why do I agree with you? Second derivative is probably the way to go.
Because I don't know where that is.
I have no idea what that number is. You could probably figure it out, but it's hard. So just don't. So second derivative. All right, so let's find a second derivative then. Notation, be careful. I'll just go back up here. Second derivative. All right, the second derivative of that is going to be 4 pi plus 4,000 times r to the negative 3. Right, I've just used my normal deriving here. The derivative of this, why do I not need the product rule to find the derivative of 4 pi r? Because pi is a constant. Good, don't fall for that mistake. All right, then this one here, we bring the negative 2 out the front and we drop the power. Now I am looking at this and thinking even more, wow, this was a great decision, Mrs. Tucker. Why am I thinking that? If I rewrite this, how would I rewrite that so there's no negative indices? R what on the bottom? R cubed on the bottom. Have a look at my R value. It's a cubed root. So what's going to happen? Oh my gosh, it's going to be beautiful. 4 pi plus 4,000 over the cube root of 500 on pi, all cubed. So it's 400 over 500 on pi. Now, that number there, what can you tell me about that number? Great. Do I need to know anything else about that number? No. You just need to be able to tell me, is it positive or is it negative? Please do not spend valuable time in your exam simplifying. Yeah. Up here, you'll need to show me that you can sub in the critical value of r into that derivative, but you could probably say it from here. You could say, right, that's greater than 0, therefore minimum at r equals cube root of 500 on pi. I'm okay with that, but I need to see that substitution in the second derivative.
Yeah, or at least say something like, when r equals this, r cubed is also positive. Therefore, 4 pi plus 4,000 over r cubed when r is this must be greater than 0. You know, it kind of just stating out, you don't, like, you just rationalize each line. But yeah, absolutely fine to justify clearly all the way through.
Yeah. All right, so then the question says, what dimensions? Dimensions, what sort of dimensions is the question asking for? Height and radius. Are you going to spend time in this exam finding the volume? Nope, it didn't tell me what the volume was. So we've got the minimum radius, and now we just need to go back to that formula that had height in terms of radius. There it is, 1,000 on pi r squared. H equals 1,000 over pi r squared, which equals 1,000 over pi times. All right, we've got 500 on pi, all to the power of a third. All of that then squared means it's going to be to the power of 2/3. 1,000 over pi times. This is not looking very nice, is it? Just leave it as that, you reckon? The pi, yeah. I think the pi's are going to cancel to an extent, so we might just do that. We'll do the cube root of 500 squared over pi. No, pi. No, that doesn't even cancel. 2, 3. I don't think that's a good motto. Yeah, okay. Tech free, sub in. Tech active, give me an actual answer. Who's got a calculator? You should all have calculators because you received an email yesterday saying how important they are. Good job. Here, have a pat on the back. I would just sub in here. Come on. All right. And what about the radius? Thank you, Em. All right, so that is, wow, it's half of the, is it half? So then it really must simplify nicely. So what have we done wrong? Anyway, I'll have a play with that in a bit. Just leave it for now. All right, guys, last one. Off you go. All right, so the population of a colony of frogs rises and falls according to the breeding season. The population can be modeled by this equation here, where the population is 100 sine of pi t on 2, all plus 500, where t is the number of months since the beginning of the year. A says, can you find the population at the beginning of the year? So what is t at the beginning of the year? 0. So we sub in 100. We are solving for when the population, what the population is when t is 0. Okay, so you need to solve 100 sine of 0 plus 500. 0 is here on our unit circle. That is the coordinate 1, 0. Is sine x or y? Nice. So that means that sine of 0 is 0. So the population, I would not expect this many lines of working, is 500. You are not getting full points for that. Please remember, we need population at the beginning is 500 frogs. At least write 500 frogs. All right, find the time at which the population is the first time the population is the greatest. So if PT equals 100 sine of pi t over 2 plus 500, what do we need to find? The max. Okay, how do we find that? Yep. Find Pete. Excellent. Good. I hear the right notation being discussed around the room. Find when the P dash T equals 0. So the derivative of sine is cos. We need our chain rule here, guys. Oh. So the derivative of this function is... All right, sorry, the recording just cut out, so I'm going to come back in now. So you find the derivative of P of T, which is going to be sine goes to cos. We keep the brackets exactly the same. We take the derivative of the inside. This is using the chain rule here, which is going to be pi on 2, and we multiply 100 by pi on 2. And we need to make that equal to 0, and obviously the derivative of 500 is just 0. So that's going to simplify to 500 pi cos of pi t on 2 equaling 0, which is going to equal 0 when cosine of pi t on 2 equals 0. You can think of using a dummy variable here. So if we let theta equal pi t on 2, we can solve cosine theta equals 0. When does cosine, that's the x variable, x coordinate, sorry, equals 0? It's going to be when theta equals pi on 2 or 3 pi on 2, and you go on in pi, up in pi increments. So therefore, pi t on 2 has to equal pi on 2. That's the first time that this happens, which is at t equals 1 when you solve that equation, or 3 pi on 2 has to equal pi t on 2. And if I multiply both sides by 2 and divide both sides by pi, that's going to mean that t equals 3. So we've got a few solutions, and you can see that it's pretty much happening every time you add 2 to t, 1, 3, 5, 7, etc. So now we have to find out which one of those is going to be our first maximum. So now we need to find the second derivative of t, which is going to be equal to, right, we're going to have 500 pi squared on 2 negative sine pi t on 2, which simplifies to negative 250 pi squared sine pi t on 2. And we're going to sub in t equals 1 into that to see if it's going to come out positive or negative. So p double dash t, p double dash of 1, negative 250 pi squared sine of pi times 1 and 2. Sine of pi on 2, that's 0, 1 is 1. So we've got negative 250 pi squared times 1, which is negative 250 pi squared, which is less than 0, which means it is a maximum. So the question, going back to the question, says the first time at which the population is greatest. So therefore, first time that population is greatest is at t equals 1. And we'll just double check. T equals 1 is the number of months since the beginning of the year. Right, there's lots of questions that you can practice on OneNote. Please make sure you're visiting them. If you have any questions that you're stuck on, please put it on the collaboration space.